Imagine this. You're at the open door of a plane, almost 4 kilometers up. The wind is loud, your heart is louder, and then you step out. For a couple of seconds, it feels unreal, like slow motion. Then it's time to pull. You reach back, grab the handle, and pull hard. Nothing. No snap, no drag, no canopy above your head, just air screaming past your ears as the ground starts rising. You pull again, still nothing. And in that moment, you realize something terrifying. You don't have time anymore. You have seconds. So here's the question. If your main parachute fails and your reserve fails, is there anything you can do to survive? Before we go further, a quick disclaimer. Do not ever try this. Don't test anything. Don't imitate anything. This is a thought experiment for understanding risk and physics, not a challenge. Now, let's talk about what you actually have in a situation like this. From a few kilometers up, a human reaches terminal speed very quickly. In plain language, you have about a minute, give or take, before impact. A minute sounds long, it is not long. So we need a plan that is simple, fast, and ruthless about priorities. This is not a motivational speech, this is a physics problem. And physics is brutal, but it is also honest. Your odds come from 3 things only. 1. How much you can slow down. 2. Where you hit. 3. How you take the hit. So we're going to build a survival plan in 3 steps. Quick reality check. In real life, the most important survival move happens before you ever leave the plane. Training, gear checks, proper packing, altitude awareness. That's where emergencies usually get solved. Also, most failures are not nothing opens. They're partial problems, twists, tangles, a bad shape, a slow deployment. And normally you have a reserve. If you ever get any fabric above you at all, fight for it. Even a messy, imperfect canopy can reduce your speed massively. Never throw away drag. But today, we assume the nightmare. No usable parachute. You're just falling. So what now? Step 1. Slow down. The moment you leave the plane, 2 forces start fighting over your body. Gravity pulls you down, speeding you up. Air resistance pushes against you, trying to slow you down. At first, you accelerate fast because drag is weak. You can feel it in your stomach. The speed builds instantly. But as your speed increases, drag increases dramatically. Not linearly. Much faster than that. Eventually, drag becomes strong enough to match your weight. When those forces balance, you stop accelerating. You're still falling, but now at a steady maximum speed. That steady maximum is terminal velocity. For most people, belly to earth, terminal velocity is roughly around 190 to 220 kilometers per hour. If you point straight down like a dart, head first, you can go far faster. That difference is the whole game. Here's the key idea. Terminal velocity depends on things like your shape and how much surface you present to the airflow. You can't change gravity. You can't change the air density in any meaningful way. You can't suddenly change your body mass enough to matter, but you can change your shape a lot. So the rule is simple. Do not become a bullet. If you tuck into a dive, you get smaller, you get faster, and you die faster. Your goal is the opposite. You want the most drag possible. Go wide, arms out, legs out, chest down, make a big X. This is the stable skydiving position for a reason. It increases your surface area, increases drag, and lowers your terminal velocity. Think of it like this. You don't have a parachute, so you turn your whole body into a small, weak parachute. It will still be terrifying. But slower is always better. Stay stable. One more thing matters here. Stability. If you start tumbling, you lose control. You can't steer, you can't pick a landing zone, and you might end up head down without meaning to. So keep the X. Keep your hips and chest facing the ground, and keep your head looking slightly forward toward the horizon. Arch slightly, like skydivers do. Stable is survivable. Unstable is chaos. People always ask, should I drop something heavy to slow down? Shoes, backpack, helmet, whatever. In free fall, losing a small amount of weight changes very little, and some of those items protect you. So unless something is actively pulling you into a spin, keep your gear on. Your best control is not weight, it's shape. Step 2. Pick where you land. Once you're stable in the X position, you can also steer a little. By angling your body and adjusting one arm or one leg, you can track through the air. A trained skydiver can travel a surprising distance horizontally. As a beginner, your control is limited, but even limited control can still change everything. Because landing location is not a detail, it is the difference between instant and maybe. So what do you aim for? First, let's destroy the biggest myth. Water is not your friend. From a high fall at high speed, water behaves almost like a solid surface. It does not compress like air. If you hit it fast enough, it's basically a wall. And even if the impact doesn't kill you, there's a second danger. You can black out and drown. So if you have any choice at all, do not aim for open water. What you want instead is anything that can steal energy by bending, breaking, or compressing. Because what kills you is not just speed, it's the sudden change in speed. A softer landing zone spreads that change over more time and distance. That reduces peak force on your body. So your best bad options look like this: deep snow, swampy ground or mud, thick bushes or dense vegetation, a forest canopy with a warning, a sloped grassy hillside where you might slide. Anything that collapses, deforms, or breaks instead of staying rigid. Trees are complicated. A tree can save you because branches can slow you down in stages. But a tree can also kill you because branches can act like spears, or you can slam into a trunk. If you're forced to choose trees, the goal is to hit the canopy and let branches break your fall gradually. You want many small impacts, not one massive impact. Avoid aiming directly at a trunk. Avoid a clean open gap that sends you straight through to hard ground. And if you can choose, denser canopy usually means more braking. What you want to avoid at all costs: concrete, asphalt, rock, rooftops that don't collapse, packed dirt, flat hard ground. They don't absorb energy. You absorb energy. Also avoid obvious secondary killers: power lines, highways, fences, sharp structures. Surviving the impact just to be cut, electrocuted, or hit by a car is not a win. Step 3. How to hit. Now comes the last brutal part. Even with maximum drag, you are still falling fast. So survival becomes a game of protecting your brain, your spine, and your vital organs. Here's the strategy. Stay belly to earth as long as you can to keep drag high. Then, right before impact, try to rotate to a feet down posture. Important detail: if you go feet down too early, you become smaller and faster. So you keep the big, draggy posture until the last moment you can. Then you rotate. Not perfectly upright like a statue, more like a controlled drop. Legs together, knees slightly bent, ankles and knees not locked. Why feet down? Because your legs are the best crumple zone you have. They can absorb impact energy through fractures and joint compression that would otherwise travel into your skull, spine, and chest. Protect your head. Tuck your chin. Bring your arms in. Shield the sides of your head and your neck. Do not reach out with straight arms to catch yourself. That snaps arms and drives force into your shoulders and spine. If you hit something that lets you slide, slide. Sliding is good because it spreads the impact over distance. And if you survive the first contact and still have any control, try to roll. A roll spreads force over time. It is the same reason paratroopers use landing rolls and why athletes roll after a fall. After impact. If you're alive after impact, it will not feel like a victory. Expect severe injuries, broken legs, shattered ribs, spinal injury, internal bleeding, head trauma. This is where the second mistake happens. People try to stand up. If you suspect spine or head injury, do not move. Do not test your legs. Stay still and call emergency services immediately. If someone is with you, call for help. Control bleeding with pressure if it's safe. Keep the person warm. Treat for shock. If you're alone and your phone is reachable, call without sitting up. Use voice control if you can. The goal is simple. Get help fast without making the injury worse. So can you survive a no parachute jump? Most of the time, no. But if you want the best possible odds in the worst possible situation, focus on what actually matters. 1. Maximize drag. Wide X position, stay stable, avoid tumbling. 2. Steer towards something that compresses or breaks, not something hard and flat. 3. Stay belly down for drag, rotate feet down at the last moment. 4. Protect your head and neck, then don't move and get help immediately. If you want more scenarios like this, comment the next situation. Avalanche, sinking car, getting lost in the mountains, plane crash landing. And we'll build the survival plan step by step. See you next time.